Hey everyone, welcome back. In this video, I wanted to show a recent design for a backloaded horn. And so this video is going to look at the design and then the prototype build along with some test data and my listing impressions. So just sit down, grab a coffee, and have a look. So for this, we're using the Fostex FE108NS. And so for this application, what we're doing is it's for small to medium sized listening rooms, near field listening, which is around 2.5 meter listening distance. The intended amplification would be low power tube amps, 300B 45 bass tube amps. And then the average listening level would be around 75 dB, which is low to medium. The design goals, wide baffle, and so you can see here the design uses a 30 centimeter or 12-inch wide baffle to kind of boost the output through the critical mid-range. And also we want clean step response within the first few milliseconds and stronger. I already mentioned the output. The main thing would be the flat frequency response. And I can say from testing some drivers recently, I tested a 5-inch woofer and a very small cabinet that wasn't much bigger than the driver itself, and I was quite shocked at the irregular frequency response through kind of the critical 1 kilohertz region. And so by widening that baffle out, it certainly flattens the frequency response through that 1 kilohertz region, which is very much affects the overall presentation for vocals. So the backloaded horn is something that's new. It's something I'm going to be focusing on a lot this year, and so this video will go a long ways towards explaining why. Mainly due to the fact that nearly all my customers are using low power tube amps, and so I feel as though if I can develop speaker cabinet designs that have true high sensitivity, then it can better serve my customer base. So we're maximizing the sensitivity, particularly in the bass and in the mid bass region. So the other benefit of the backloaded horn is that it reduces the diaphragm movement. So the driver's moving a lot less to produce the same output of sound, and so that is going to reduce distortion. And so the design goal for this cabinet was to have it as basic construction as possible, so no compound angle cuts, no angle cuts at all actually with this design. And so the cabinet uses 12 millimeter thick Baltic birch plywood. And so just a bit of a backstory here. Why am I looking, I covered kind of the rationale with the low power tube amps, but up until recently, I had written off backloaded horns as not capable of producing the bass quality that I was looking for. However, when I was at high-end Munich, I was invited to Klangloft in Germany, which is, I think, one of the largest distributor retail high-end outlets in Germany. And so they had the Arias Surat Symphonia set up, which is an 8-inch backloaded horn. You can see it pictured here. So it's also a Fostex, but it's just being used for bass and mid bass. And so the bass quality from this was just incredible. Very clean, very deep, lots of authority and power to the sound. And so it put this configuration back on the radar for me, and it was something that I decided I wanted to pursue further. And so with just kind of a background on how the backloaded horn works. So it takes the back wave of the driver and it amplifies that, and it amplifies both the bass and the mid bass up to around 300 to 400 hertz. And so the backloaded horn is the most difficult type of enclosure to design successfully. So as with any horn design, there's many pitfalls along the way. So the goal with the backloaded horn is obviously to amplify the bass and mid bass, and it can provide up to 9 dB increase in sensitivity if it's designed properly. So to provide that kind of gain, it requires an exponential flare rate. And the second thing is that it requires a tortuous passage to diffuse the mid-range frequencies. So there must be random passage lengths, and so that it diffuses a variety of frequencies beyond that kind of 300 hertz and up. So you want it that mid-range attenuated down for what is coming out of the horn mouth. So the sharp bends break up the mid-range energy, preventing escape out the horn mouth. So to create a path length that is long enough to produce the desired horn cutoff frequency, which is the FC, but not too long so as to introduce group delay. So this is a balancing act, and I've noticed a lot of designs make the horn length too much. They're trying to get the bass extension to go down to 30 hertz or 20 hertz, and that just has compromises further up into the frequency spectrum, where the group delay is just so much that you actually notice a separation between the direct sound from the driver and the output of the horn. And so there's a balancing act there. So you must pick a target cutoff frequency that matches also the natural rising response of the driver. And so if you place a low QTS driver, which means high motor strength, onto a regular baffle, it's going to have an aggressive rising response. As you move up into the mid-range, you're going to get increasingly more output. And so it's a balancing act of designing the horn so that it complements that rising response, so that the horn is filling in the mid bass and bass so that it sums to a flat response in room. And so the design also has to take into account the room boundaries that are going to be contributing to the output, such as the rear wall, the side walls, and the floor. And so those room boundaries can actually be used to your advantage to continue that horn path out into the room. And so the room is actually acting as an extension of the horn. And so that's something that you can take advantage of, and then actually make your cabinet smaller by virtue of it continuing on into the room. So there's always going to be a cancellation dip in the mid bass around 150 hertz region, and this is common with this particular design. It's not going to be a peak in the response, but it's going to be a dip, and so that's something that's expected, but we want to try to minimize that dip by providing as much output out of the horn as we possibly can, so that you have a bigger ratio between the output of the driver and the output of the horn. If that horn is producing 90% of the output, then there's going to be a lot less severe dip and a much smoother frequency response in room. Okay, so I use horn resp to simulate the kind of the preliminary design of the backloaded horn in terms of what's the throat area, what's the horn length need to be, and what's the mouth area for the given driver that we're using. And so you can see here that we have only a 20 square centimeter throat area, so very small. The rear chamber is basically non-existent. The driver has no internal volume behind it. It's maybe a quarter of a liter. And so the driver is actually under a lot of stress, having to drive that sound energy through that small throat opening, and then the sound travels 3.3 meters before it exits out. And so that length is required to produce the lower bass frequencies. So this particular design, we're targeting a 45 hertz low frequency extension, which is kind of a reasonable target to set for this type of application. So you can see here, this is the resulting frequency response simulation. You can see it looks pretty terrible, but we're just basically wanting to confirm 105 dB sensitivity in room, and then bass extension to around 40 hertz. And so this is something that can be ignored because the simulation in the software does not factor in the tortuous path that we're going to create, which is going to diffuse and break up those mid-range frequencies. And so you can see here, this is the system diagram with our 20 square centimeter throw area, and then expanding out into a 400 square centimeter horn mouth. And so you can see here, this is the cutaway of the design, where we have tortuous passage immediately behind the driver, and so the sound has to pass through all these 90-degree angles at various path lengths, which captures the cancellation of various frequencies, and it's kind of randomizing those reflections so that what you get coming out of the horn mouth is just bass and mid bass. And so hopefully if we put a microphone up to that horn mouth at the bottom of the cabinet, we should see those mid-range frequencies just fall off like a rock at around 500 hertz. So like I mentioned earlier about taking advantage of the room boundaries, I initially had the back of the enclosure covered so that the sound came out the front, but then I realized, well, based on the simulation, if I can get even more horn mouth area, then the bass is going to be even that much smoother. And so I removed the rear, and so you have these kind of two legs supporting the rest of the speaker, and so the sound travels down, out, and then it goes in both directions, forward and back, and then it can use the rear wall boundary to kind of even further extend the horn path. So building a first prototype there from 12mm Baltic birch plywood. You can see here these are just the pieces loosely assembled, and installing the driver, set up in my listening space, and we quickly realized that we need to get two of these built. And so just to evaluate as a stereo pair, early listening impressions were very positive. There was significantly more bass than any other cabinet design I've come up with for this size format, which is 4-inch. And so the bass quality coming from this was similar to more what you would expect from an 8-inch driver. And so getting that 9 dB gain and sensitivity from the horn, coupling to the room acoustics, you get a lot more energy in this design versus bass reflex or transmission line. Okay, so in-room measurements, and so you can see here, can't do outdoor measurements because we're in the middle of winter here in Canada, and so just applied 1/3 smoothing. So you can see here that there is great bass extension down to around 35 hertz, and so we're exceeding what our simulation predicted. And then we have our cancellation dip, like I mentioned earlier, at around 145 hertz. So bass sensitivity at the 70 hertz, we're seeing 92.5 dB, and so that is pretty good for a 4-inch driver. To highlight that even further, what I wanted to do was look at the actual sensitivity of a variety of other speakers, just to see. A lot of manufacturers like to embellish their sensitivity ratings, and so this I felt was a good time to just measure the sensitivity of a variety of other speakers at 70 hertz, 2.83 volts, which is the 1 watt, and see how they compare against this backloaded horn. And so I've just summarized in my blog post the sensitivities that I was measuring at 1 meter using my decibel meter with the 1 watt. And so the Mark Audio CHR 120, which is a 6.5-inch full range driver, measured only 75.5 dB. And so we see a significant drop in sensitivity comparing with this backloaded horn. And so we have a real 92.5 coming from this design that I've come up with. And the other one was a 6.5-inch two-way stand mount speaker that uses a CS 6.5-inch woofer. It as well was 76 dB. Another Fostex 6.5-inch full range in a transmission line produced 90 dB, and the 1630 speaker, which uses two 5-inch ScanSpeak woofers and their 4-ohm drivers, which are wired in series for an 8-ohm nominal load, that was 89.5. And so we're seeing a significant increase, basically about 3 dB against the best of the others in the group test. And so that equates to basically twice the amount of output power from a 4-inch backloaded horn. So I guess the overall point that I'm trying to make here is that the backloaded horn is providing very useful, meaningful output for those that are using low power tube amps. And so it's a true to life high sensitivity. Another thing I wanted to look at too is just measuring the output of the horn and seeing what the frequency response looks like of just what's coming out of the horn. And so you can see here it has bass, a significant amount of mid bass, and then by 500 hertz we have a steep drop. So the tortuous passage that I mentioned earlier is certainly doing its job. And you can see here with the horn rasp simulation, it's not predicting anything as far as the tortuous passage because it's just simulating a straight horn. Looking at the difference between the blue line here is with the speaker, the backloaded horn, positioned in the middle of my test area, and then the red line is actually it positioned 30 centimeters from the rear wall. And so it's using the rear wall boundary to drastically, you get about almost 10 dB increase there at 40 hertz by having a rear wall as boundary reinforcement, bringing up those bass frequencies. And we also see that it's bringing up those mid bass frequencies as well. And another thing that we notice is the cancellation dip is more severe. So some trade-offs there. Obviously you want the increased bass output from the room boundaries, but you're seeing a bit of a cancellation dip there as well. So distortion measurements, I don't think I'm going to bore you with the distortion side. Measuring it at the 75 dB test signal, we saw the IMD at minus 55 dB. So an excellent result for intermodulation distortion. And so you can take a look at that. And I left the link to the blog in the description. So just some other renders of what the cabinet design would look like with different finishes there. And so I did offer a very detailed analysis of the sound quality in my blog, and so I have a link to the various test tracks that I used and kind of what I was observing with the various test tracks for bass and mid bass and that. But just to kind of summarize, that the bass is very very nuanced and palpable. Those are the words that came to mind when listening, and it has a way of coupling to the air in the room, and that's one big thing that I noticed. It sounds like a much bigger driver. Like I mentioned, it sounded more like an 8-inch driver, and so that's when you kind of put your head near the horn mouth. It's incredible how much overall sound power is coming out of that that 400 square centimeter area there at the bottom of the cabinet. And so it's just much more energy coming out of that horn mouth compared to the direct sound from the driver. And so it's an interesting design. It's very popular in Japan, and so it's just kind of bringing back to life a design and revisiting something that I would never have considered had I not heard an excellent execution of the design with the Arias Surat system, the Symphonia. And so there you have it. That concludes my video for today. So wide baffle backloaded horn number 2314. Take care and have a great day.